Well, we'd like to welcome you to this session. My name is Matt Warner. I'm with the American Legislative Exchange Council. I've been asked to moderate today's esteemed panel on climatology. At the American Legislative Exchange Council, we're a membership organization of state legislators, and one of our initiatives is to improve the access to science and scientific understanding for our elected officials. And we certainly express gratitude and a salute to the Heartland Institute for all the good work that they're doing. And I'm furiously taking notes at this conference and looking forward to sharing some of these things with our members, some of whom are attending. We'll go ahead and get started, so we'll have plenty of time for today's presentations and the Q&A. We'll do 3 speakers in a row, 20 minutes each, and then we'll have a question and answer period. Our first speaker will be Dr. Patrick Michaels. He's a senior fellow in environmental studies at the Cato Institute, which is a research and education foundation think tank in Washington, D.C., and a research professor of environmental studies at the University of Virginia. He's also a visiting scientist with the Marshall Institute in Washington, D.C. He is a past president of the American Association of State Climatologists and was program chair for the Committee on Applied Climatology of the American Meteorological Society. Michaels is a contributing author and reviewer of the United Nations Intergovernmental Panel on Climate Change. His writing has been published in the major scientific journals, including Climate Research, Climatic Change, Geophysical Research Letters, Journal of Climate, Nature, and Science, as well as in popular serials. He was an author of the Climate Paper of the Year awarded by the Association of American Geographers in 2004, and in January 2009, very recently, published Climate of Extremes, Global Warming Science They Don't Want You to Know, which is his 5th book on climate change. Please welcome Dr. Patrick Michaels.
Many thanks for having me here. Now to go to the next presentation, hit Escape and click on the bar. And let's click on the bar and go slide show. F5. F5. Ready to go? Yeah, great. Okay. All right. This is a little bit different subject matter than I would normally address. I got mired in the reviewing of several documents that were solicited for public comment. This is the ANPR, the announcement of proposed rulemaking on carbon dioxide by the EPA. And then this is the Climate Change Synthesis, our science program, CCSP. And I came to the conclusion after reading all of these that they were USBS. And I will show you why. Now, I'm not giving you all the review because the reviews turned out to be about 168 single-space pages, and much of the work was done by Chip Knappenberger sitting over there in the back row. There are certain areas in it, such as air pollution, that I leave to Schwartz, who helped us on that, and I'm sure he's presenting that here anyway. So anyway, the ANPR had a scientific rationale, which is called a technical support document, yet another acronym, TSD, for endangerment analysis. Now, before we go any further, all these documents are based upon models. For the climate change issue, we could examine the suite of 21 climate models for their mid-range emissions scenario. That's called the A1B suite. And we're actually going to look at the frequency distribution of the rates of warming that are projected by these models for various lengths of time. And we can run them time after time after time after time, so we can get very large sample size iterations to generate the true statistical frequency distributions of the rates of warming in these models. That's a reasonable thing to do. And then we can compare the observed rates of warming for various lengths of time to those that are projected by the models and determine the 95% confidence limits for the frequency distributions. And if an observed rate of warming fell outside or at the 95% confidence limit, either too warm or too cold, we would say that we could not continue to entertain the major hypotheses produced by the models. That's science, okay? That's the way you do science. And there's precious little of that done in this discussion. So remember, first you put carbon dioxide in the atmosphere, and then that is put into a computer model for the atmosphere, and then that produces climate impacts, which produces proposed rulemaking by the EPA, or produces documents like the Climate Change Science Program synthesis documents that are the matter of this talk. Well, just for grins, let's take a look at the observed global temperature history from 1977 through 2008. The best mathematical function that fits it is a straight line. Yes, there is this interesting issue of the last 2 years. I agree, it's very interesting. But we're going to take a look at trends on back to 15 years, which would be 1993 on up, and then 20 years back to 1988 on up, and see how those match the trends that would be predicted by the computer models. Here's what the models predict, and here's why this becomes an apples and apples comparison. This is the A1B suite of models. Each one of these colored pieces of spaghetti is a climate model. The dotted line is the central tendency, or the average of all these models. There is a belief in meteorological science and weather forecasting, which I've also taught, that an ensemble of forecasts tends to do better than an individual forecast, and there are economic arguments along those lines. But anyway, I'd like to point out the central tendency is for warming to occur as a straight line. That's because of an exponential increase in carbon dioxide and a logarithmic response to an exponential increase. And indeed, if you take a look at the individual models, they also tend to be straight lines too. They just happen to be different straight lines. You were just to take a look at the observed trend compared to what these models are projecting, you will see that it tends to be at the low value. Now let's just examine in detail the period 2000 to 2020. That's just to beat the horse to death, that there is obviously a constant rate of increase projected, and we are roughly at the midpoint of this. And we have established that the trend is in fact linear. So now in the observed temperatures, so let's take a look at the results of our study. These are the 95% confidence limits of this ensemble of 21 models for trends of different length. 5 years, 6 years, 7 years, and these are the observed trends for the last 5, 6, 7, et cetera years in degrees C per decade. And you can see what has happened is that this is the 95% of the model results are within this gray area. So this is actually the 0.025 percentile, if you will, in these models. And the observed temperature trends are falling right at the failure point of the models. If this were a court case, if this were a tort case, Dalbert versus Merrill Dow, run by the Supreme Court, would say that there could be no award to the plaintiff. And oh, do I hope that the Congress decides, the Senate decides not to vote on cap and trade, or doesn't close debate, and that it will go back to EPA for regulation, because then that will probably form a challenge on this subject. By the way, it gets worse if we put in the current temperatures just for the heck of it. This is, if you include 2009 will be the same anomaly as 2008. The model failure is basically at all the lengths and time. Now you could say, oh, Michaels, you're picking on the last 15 years, and everybody knows there's something funny about the last 15 years. So let's do the same analysis for 20 years. And here are the trend lengths out to 20 years. Now, in 1991, a volcano blows up called Mount Pinatubo. Computers don't have volcanoes in their models, otherwise they'd blow up. So what we do is we take the effect of the Pinatubo temperature change out of the observed temperatures, which is kind of easy to do. We published a paper on that and so have many others. And what you see, it's very interesting, is that it is clearly failing any reasonable test of statistical significance at the 0.025 one-tailed level or the 0.05 two-tailed level. This is a flop, okay? And this is going to come out in public. It's going to come out in public more and more and more. So the basis for the ANPR as well as the climate change science program impact work, is just not right. Now, I was going to go through a few specific examples of this and show you how bad it can be. Global mean surface temperatures have risen by 0.74 degrees C over the last 100 years. The rate of warming over the last 50 years is almost double that over the last 100 years, with an increased rate of warming over the past 30 years. That's totally misleading, because there are two warmings in this record. Everybody knows that this one is largely caused by the sun, and that some people will ascribe much of this warming to greenhouse warming. But to go back and start in 1950 and say the rate of warming increased in the last 30 years from what it was in 1950 is nonsense. There wasn't any warming in 1950. And the warming before that could not have been caused by greenhouse emissions. Surface temperatures over land have risen about 0.27 degrees C per decade. McKitrick and Michaels, Ross talks about this too, went to see if that's right by looking for biases in the land temperature record. We looked for non-climatic effects in the IPCC, Intergovernmental Panel on Climate Change history, and we put in factors such as GDP growth, things that would affect the quality of an economy, things that, look, in Chad, how high is it on the priority list to make sure that the weather station remains painted white? No. So it gets dirty, and therefore it gets warmer. How high is there pressure for quality data collection in poor countries? It's pretty low on the priority list. Anyway, we found a whole series of factors that were significant predictors of the rates of warming from place to place over land: GDP density, literacy, the base satellite temperature, population growth, income growth, coal consumption, all these kind of things. And this is the difference between the observed and adjusted temperature in degrees C per decade when we adjust for what we found. And you can see here that green and these yellows and greens and these colors are very little adjustment. Where it's red, the data are way too warm. And as you can see, where people are poor, the temperature is hotter than it really is. In fact, if we take a distribution of the observed trends of warming, almost like what we did before, and look at the surface temperature of the IPCC, this is the frequency distribution of warming from place to place, and you can see this big, long, hot tail. This is the frequency distribution of temperature change in the satellite records, the raw satellite records. You'll notice that it has very small tails. It doesn't have extreme highs and extreme lows. And when we took out what we call non-climatic factors from this record, guess what disappeared? Were the two tails. Satellite is always accused of being non-biased compared to the surface record, which is probably true. So in fact, there is a significant non-climatic warming in that record. The record, the technical support document for the EPA, talks about long-term trends in U.S. precipitation and how unusual it has been during the last 3 decades. How hard is it for Chip over there to plot up the trends in 30-year trends throughout the entire record, beginning in 1895? And what you can see here's the trend that should be the last 30 years. That's a misprint there. It should be 1978 to 2007. But anyway, what you see is there's absolutely nothing unusual about the recent trends. Wrong. Antarctic sea ice extent, however, shows no statistically significant average trend. That is just completely wrong. And how my profession could let such a statement stand? The sea ice is available from the University of Illinois for the Southern Hemisphere. You can pass a line through it, and it's significant at the 0.0001 level. This is the kind of stuff that's passing as the excuse for regulation in this country. Melting of Alaskan glaciers conflated with global warming. Alaska's temperature record is a very interesting temperature history. In the Great Pacific Climate Shift of 1976-1977, whose signature was the spasm of the insanely cold winter in North America of 1976-1977, the Alaskan temperature jumped. Here, it was warm in Alaska, very cold in the rest of the North America. And since then, there's no net change in the Alaskan temperatures. There isn't a computer model on the planet that predicts such abrupt climate change. So that's not real. The latitudinal patterns of change in land precipitation appear to be consistent with the response to atmospheric anthropogenic forcing. Wrong. This is from Zhang et al., 2007. Where it's green, precip is going up and was predicted to go up. Where it's yellow, precip is going down and was predicted to go down. Where it's gray, they're wrong. That looks to me like most of the mid-latitudes of the northern hemisphere, including all of the United States. And the climate change science program is about climate change impacts in the United States. Okay, it's wrong. It's not right. The climate change science program forecasts negative changes in the Pacific Southwest of 3 inches per year. It conveniently forgets that over the course of the last 100 years, the precipitation in the Pacific Southwest has gone up by 1.5 degrees, or 1.5 inches per year. So the actual change that they're predicting would be a decline of 1.5 inches per year in 100 years, which is an amount that's probably too small to really notice in the long run. Complete disintegration of the Greenland ice sheet would take many hundreds of years to complete. That's the technical support document for the EPA report. Well, here's the UN's model for loss of ice in Antarctica. It assumes it doesn't lose all its ice in year 1760. And this assumes that CO2 goes to 4 times the background, or over 1,100 parts per million, and stays there for 2,000 years. Does anybody believe that? Does anybody believe we'll be burning fossil fuel at that rate 500 years from now? 100? I don't think anybody does. You know, this is like the Roman Curia in the year 1000, saying based upon current trends, there will be 300 billion Catholics in the world, and 99.9% of the world will be Catholic. You just can't make 1,000-year predictions. EPA cites IPCC's projections of increased flood damage in the United States. Wrong. Flood-related damage per unit GDP shows no significant trend at all, down than in all 2005. We just say things that are wrong because we want to legislate things, or we want to make rules. EPA claims increased U.S. damages from hurricanes as the planet warms. Wrong. Pilkey et al., 2008. You have to adjust for how many more houses, beach houses, have been built along the coast. You know, in our society, we take all the money we made in our so-called productive life and throw it in a sand dune on a hurricane-prone beach. And then the hurricane comes along and blows the house away, and the people of the United States help us rebuild our house. It's a great country, isn't it? Anyway, there's actually no trend after you allow for population levels and property levels on the beach. This one. This says West Nile virus spread was linked to global warming. That's pretty cool, because West Nile virus started in New York, okay, and then spread not north, but south and west across the United States. It spread into a warmer and warmer climate. So how do you conflate West Nile virus with planetary warming? Well, you can't. St. Louis encephalitis, this is from the technical support document, page 68. St. Louis encephalitis has a tendency to appear in hot, dry La Nina years. What? Hey, O'Brien. The La Nina years tend to be cold. That's the last I heard. Not hot and dry. And the IPCC projects no change in La Nina frequency. And this is the human encephalitis, St. Louis encephalitis case by state, 1964 to 2006. If you can see any pattern in this data, I'd like you to reveal it to me. And if you can see any pattern that is related to be La Nina being cold and dry, I'd like to see that too. But it's just not there. Is there any trend in St. Louis encephalitis? After all, the planet is getting warming, and we're asserting that there will be trends in St. Louis encephalitis, so why don't we actually take a look at the data? And as you can see, well, there isn't any. These things are not that hard to look up. The great Chip Nachmanberger can do this stuff really fast. Now, that doesn't mean you all go call Chip, okay? Unless you chip in to Chip's kitty, and then Chip will be happy to work for you. This is one of my favorites that Chip did. The northern limit of the tick that causes Lyme disease could shift north 200 kilometers by the 2020s. In reality, the tick lives in cold climates, okay? This is where the cases are, and they're going to shift north. Get that? And that's going to affect Lyme disease in the United States. It's absolutely astounding. Mortality in global warming in the United States. Here's age-adjusted mortality, crude mortality, and here's temperature in the United States. This is obviously a major factor in it. Climate change endangers U.S. agriculture, according to the technical support document. Well, here's the mean temperature of the United States. Here's corn yields. They've gone up by a factor of 5 Look what they did as the second warming of the 20th century occurred. You can see they obviously fell. Here are wheat yields, and here's precipitation across the United States going ever so slightly up, and crop yields going up fivefold and doubling for wheat. Why? Because we adapt. This is the adoption of genetically engineered crops in the United States. These are herbicide-resistant soybeans, HT cotton, insecticide-resistant, or insecticide included, BT, cotton, corn, etc. People adapt to changes. And to say, come on, how many of you have gotten your Burpee seed catalog for the year, okay? Do you notice there's one in there called Heat Wave, a tomato? And it's been in there for a long time, so that on warm nights you get more fruit set than you get from standard tomatoes. You don't think that the guys at Monsanto and Celgene and God knows who are working on taking pieces of the genetic material, maybe, from sugarcane, which grows in very, very hot environments, and inserting it into corn? They're very related. Things like that can happen, of course, and they will happen, as long as we don't impoverish people so much they can't afford to do it. Don't worry, I'm almost done boring you. But the amount of bad science that's in these reports is truly astounding. April snow water equivalents have declined 15 to 30% since 1950 in the western mountains of North America. Well, that's good, okay? Yeah, you start your study in 1950. Thank you. Look at the decline, sort of, here. But why don't we take a look at the data before 1950, which exists? Go back to 1930, and you can see what they've done is they've declined back to where they were at the beginning of the historical snowpack record. And if you read my book, Climate of Extremes, which you should buy, by the way, one of the first examples in it is of how Mark Albright lost his position as assistant state climatologist in Washington State because he dared show all the snowpack data instead of the snowpack data just from 1950 to 1996. And guess what happens when you show all the snowpack data? Same thing that happened here. Why? Because they're snow water equivalents, okay? So when you show the whole truth in climate change, you get fired or you have to leave or something like that. To view the entire sad story, I actually put it up, all 168 single-space pages, on the website at Cato. Heartland has my PowerPoints, so don't bother writing it down. You can get it right here, but it's called Shaky Science, Inconvenient Truths Ignored by the EPA in its proposal to regulate carbon dioxide emissions. And that's the end of my sad story. Just remember, not one taxpayer dollar went into this study, and all taxpayer dollars went into that junk. Thank you very much.